So here is your study guide for your test on radicals and on rational or irrational numbers. I'm going to group the first 6 questions of the study guide together. Okay, so this will be questions 1 to 6 because those are all about rational versus irrational. Then we move on to radicals and simplifying and operations with radicals. But the first 6 questions just talk about rational or irrational numbers. Now, for the most part, I just use square roots. Okay, so we're just identifying when a number in a square root is going to end up with a rational value when we take the root, or it's going to end up with an irrational value. So we said that in order for it to be rational, it has to be a perfect square number there. Okay, so is 8 a perfect square? Well, let's see, what's a perfect square? Perfect square is the value I get when I multiply a number by itself. I square the number, I get my answer. That answer is a perfect square. So when I take 1 and I square it, I get 1. So that means that 1 is a perfect square. When I take 2 and I square it, squaring means I multiply it by itself, I get 4. So 4 is a perfect square. 3 squared, I get 9. 4 squared, I get 16. And notice we got well past 8 and we do not see that 8 is a perfect square, right? We're already on to bigger numbers. So square root of 8 is going to end up with an irrational solution. And if we want to double check that on a calculator, square root of 8, I'm going to open up a calculator right here, and I'm going to put in 8 and take the square root, and I see I get this long decimal. And if you notice, there's no pattern there. It does not repeat. It also doesn't end. Okay, it would keep going and going and going if I had a million decimal places on my calculator. So that makes it an irrational number. Okay, next value we have is square root of 81. Is 81 a perfect square? Let's see. We got our perfect squares through 16, through 4 squared. So let's continue from there. 5 squared. 5 squared, 5 times 5 is 25. So 25 is a perfect square. 6 squared. 6 times 6, 36. 7 squared, 49. 8 squared, 64. 9 squared, 9 times 9, 81. So 81 is a perfect square. The answer to the question, what is the square root of 81, is 9. If we got a whole number value, then that is a rational number. So I'm going to circle rational. Let's double check that on the calculator. Okay, I put in 81. I take the square root and I get 9. I got a whole number. So since I got a whole number, whole numbers are rational. So square root of 81 is rational. Okay, then we're going to move on to adding. Adding square root of 7 plus 5 square root of 2. Now, we already went through our perfect squares, right? We saw 1 was a perfect square, 4 was a perfect square, 9 was a perfect square. 7 and 2 were not on that list of perfect squares. So that means that here we are adding 2 irrational numbers, 2 numbers that give us crazy decimals that never ever end. When we add 2 numbers like that, we still have a crazy decimal that is never going to end, okay? So square root of 7 plus 5 square root of 2 will give us an irrational solution. Question 4, explain how you got your answer for question 3. Well, I just said we were adding 2 irrational values, right? Square root of 7 plus 5 square root of 2, those are both irrational. If they were the same thing and one was positive and one was negative, they would end up in 0, so it would be rational. But since they're not the same, square root of 7 and square root of 2 are going to give us different decimals. We add them together, we're still going to have a decimal that never ends. So that's how I know that it's irrational. And you also could have said that I put it into my calculator if you wanted. You could put root 7 and 5 root 2 in your calculator, add them together and say, I saw a decimal that does not repeat, does not end, it just goes on and on and on. So I knew that that was an irrational solution. Okay, question 5. Is square root of 16 times square root of 2 rational or irrational? Okay, well, square root of 16 happens to be rational, right? 16 was on our perfect square list. So this is 4. Okay, square root of 16 is 4 because 4 times 4 is 16. And we're multiplying that by square root of 2. Do we think that will be rational or irrational? Well, if I think of square root of 2, I know square root of 2 is irrational. 2 is not a perfect square. I've got this long decimal. I'm taking that decimal and I'm multiplying it by 4. Am I suddenly going to have a nice number that ends? No, it's still going to be that crazy decimal. It's going to be irrational. And let's put it into my calculator again. It looks like I closed my calculator, so I will reopen it. On this calculator, I have to put in the number. So I'm going to put in the 2 and then take the square root. Here's square root of 2. We're multiplying that by 4. Still have this decimal that just goes on and on, doesn't have a pattern, doesn't end. So my answer is irrational. And question 6, our last question about rational or irrational. Here we are multiplying two irrational numbers because square root of 10 and square root of 10 are both numbers that are not perfect square. 10 is not a perfect square, okay? So let's see what square root of 10 looks like on our calculator. Put in 10, take the root, and you see that we have an imperfect square. However, we said that if we are multiplying the same square root, okay, by itself, we get a rational number, okay? So when I looked at this, I feel like I just said we see a number that's not a perfect square. The 10 was the number that's not a perfect square. The decimal, I meant, is what shows us that it's irrational. So I meant to say we see a decimal that goes on and on forever. That's how we know square root of 10 itself is not rational. But if I take square root of 10 and multiply it by itself like this, then what do I get? Well, we know how to multiply square root of 10 times square root of 10. We could multiply the insides. We have square root of 100. What's the square root of 100? That's equal to 10, okay? Whenever we square a square root, so we take the same square root, multiply it by itself, we end up with the number that's inside, okay? Because we're taking that number, 10, we're squaring it, we're getting 100. Now when we think about taking the square root of that, well, that's asking us what number do we multiply by itself to get 100? That brings us right back to the whole number 10. So this actually has a rational solution. And with that, we're finished with our 6 questions about rational or irrational. In the next video, I'll move on to simplifying radicals.